All right. And cool. So like I mentioned before, like I keep bringing this up, I'm kind of taking this in a little bit different, like in a different order than like what the curriculum kind of presents it in. But we hopefully today will be able to talk about A/B testing and ANOVA, so multiple comparisons. And my hope is that talking about ANOVA will kind of help us understand a little bit like when we get into linear regression of like how that relates to hypothesis testing, which I will be frank, there isn't a direct connection in the way that we use hypothesis testing in linear regression, but mathematically they're actually very related. In fact, ANOVA, I think when you see what ANOVA is like and like why we're doing it this way, you realize that how t-tests in like, you know, other hypothesis tests, how that is kind of in the sense being done, because an ANOVA really is like multiple t-tests at once. So we'll kind of talk about that today, hopefully, and maybe go into some more detail. Just next class, which will be Thursday, right? Next study group, I should say. We are going to actually skip over section 17, at least for right now. Section 17 is Bayesian statistics. Anyone in Bayesian statistics so far? Like, gone through that? All right, so if you're in Bayesian statistics, don't worry about it. Like, you can keep going through it and stuff like that. But I think what I'm gonna do is I'm gonna hold that off until after we go over linear regression, only because linear regression is a huge portion of the Mod 2 project that you guys will be doing. And really Bayesian statistics, it's important, and we'll actually kind of address it in naive Bayes when we talk about machine learning models and stuff like this. But it doesn't really directly apply to what we'll be doing in the project. And so what I'm gonna do is actually next class we'll go into section 18, introduce linear regression, and continue that forward. And then we'll finish up, 18 and then 19 and then 20. And then we'll probably then go into Bayesian statistics either during that week or kind of as we go into project week. Note that project week, like, so this kind of little, I had to like check myself because I wasn't sure if I had the ordering right. So today's the 7th of April, right? And so next week we'll go over sections 19 and 20 for those two study groups. So that's April 14th, 16th. And then the week after that, we have one more week before we start project week. And so that normally would then say, oh, well, we don't really have another section, but we skipped over section 17. So that's probably where we'll talk about section 17. And then we have an extra study group just to talk about the project before we actually get into project mode. And then that April 27th, we'll start project week. We do that for 2 weeks. So the last week of April, the first week in May, and then we'll have a break, May 11th. So we won't have any classes, no one-on-ones, no new material. And it's a good time just to kind of like be able to relax a little bit. But I mean, also it's a good time, like if you're feeling a little behind and just kind of want to get a little bit extra stuff. Plus, if you're honest, most people are kind of stuck at home. It's like, maybe I want to do something to distract myself because I can't really get out. You can kind of like get up ahead or like catch up to anything. And then when we come back on May 18th, we'll start doing project 2 assessments. So it's actually about like a little bit over a month from now, we'll start doing the Mod 2 project assessments themselves. So quite a lot of time. But I wanted to kind of get that timeline because especially the mod project will be related around, what's it called? Linear regression. Or I should say linear, multiple regression, all that stuff. So yeah, sound good? Okay. Any questions on that timeline? Anything?
For the projects in general, are we allowed to collect our own data, or are there going to be any projects where we have to like use the data provided for us?
Yeah, that's a good point. I believe in this next project, this will be the last one we actually will give you kind of like data to use. I will actually say this probably relies more in the sense of using the data provided, because the main focus is not about collecting data for this like module project. It's going to be focused instead on the technique of
Building the model. Yeah,
exactly.
All right.
But future projects, you actually be able to choose your own stuff, since now you should be familiar with EDA, since you've done 2 other projects. You should get pretty familiar with manipulating data and stuff like this. So yeah, something to look forward to for future projects for sure.
Awesome.
Yeah. Cool. All right. Yeah, nothing else then? No other questions? Cool. Okay, so I'm going to share my screen and yeah, okay. And then I'm reminding myself is that about 5 minutes before we end the material today, I'm going to talk about some admin stuff about the show and tell tomorrow. So if you're sticking around, stuff like that, if I don't know, who wants to give me a little quick reminder for like 5 minutes until the hour? Just any volunteer. Keep me honest. I only say one person because then I know there will be at least one person who will say something. Okay, no one? All right.
Sure,
Then we'll just keep.
Right. Yeah, when is it? Like 5 minutes to the hour?
5 minutes before the hour finishes. So,
I'll set
I
one.
can.
Okay. All right, got you.
Yeah. I'll try my best to remember myself, but it helps if you guys can just say something. Okay, so all right, cool. It looks like we don't have too many questions today, but let's see here. New material, section 18. So okay, this is actually linear regression. So simple linear regression, this may be a math question, but how did they get this? Yes, I will definitely hold off this for right now until we get into tomorrow, or not tomorrow, Thursday's study group, because we'll talk about linear regression. But whoever asks this question, if you are here on the call, if you can just add what lesson this is specifically, that might be helpful too. It's always helpful, especially if you guys write stuff down here. Just put down what lesson it is, because then we can refer back to it, especially if it needs more information. But we'll talk about this next time if you guys are okay with that. Cool. All right. Any questions on like earlier stuff? I just want to give that time in case you guys are.
I have a question.
Yeah, go ahead.
It was on the effect sizes, p-values, and power lab. It seemed like for the Welch's t-test degrees of freedom, it seemed like the solutions entered the formula wrong, and I just wanted to like see that.
I think you're right.
Or if I got it wrong, or if yeah, because it looked wrong.
Let's see if I can pull this up real quick then.
Thanks.
So I think if I saw this right, I think the degrees of freedom, they didn't put the -1 essentially. Like I could be wrong. Here, what section is that? This one?
Yeah.
And then is it this one or is it?
That one. Like they had us write the functions in the Welch's t-test lab, but then they have like in the Jupyter notebook, there's a Flatiron stats.py file. Yeah,
it's a little bigger. And then it was something specifically when they actually implement Welch's.
Yeah, I'll show you.
This part.
It was in the Flatiron stats py file where they there we go. Yeah, so I think
this one right here.
I think it's the one above it, the denominator. I think that's wrong.
Okay, so let's check this out real quick.
Okay.
So first of all, while we look at this, anyone else like have this issue with this specific lab or anything like that? No? Okay, that's okay. So Welch's t-test formula. Good old Google.
Right, it's faster than looking through the lesson.
100%. And I have more people to look at this. Okay, so Welch's t-test, there we go. So you can see here, it's the means, right? So this is pretty familiar.
But I think, isn't it the degrees of freedom, the V? Yeah, that
right.
one.
And this is the one that we have to look at, right? Thank you for pointing that out. So it's S1 squared, S2 squared right here. And remember S1 is representing the standard deviation. This is really the variance of the first sample, right? So if we're looking at sample 1, sample 2, right? And so we're looking at that specific one. So let's check out.
It was on the denominator. It's raised to the it's supposed to be raised to like the 4th power.
Yeah, let's check this out. This could be, I'm trying to think if they did something here. So let's see here. I think you're right, because I'm looking at this. I'm kind of going back and forth a little bit. Number of, and then degrees of freedom. So know that this is V1, this degrees of freedom. That's normally n-1 in this case, because we're looking at just the sample. So this should be, I guess, this guy right here. Yeah, I believe you're right, Jessica. I think this is supposed to be to the power of 4.
Okay, cool.
So yeah, and again, you know, mistakes happen like this. Actually, thanks for putting it out, because I can actually go ahead and I'm going to save this to put out to the curriculum team. Kind of a nice thing to know about this too is like why you should try to use packages, right? Is because usually packages will be less likely to mess up because more people are working on them versus you trying to do it from scratch, right? This is a very simple issue right here. And I believe this is, yeah, I'm just double checking that there's no like weird square root, but I don't
Okay,
think
cool.
so. Yeah, good catch. Yeah,
I have
okay.
I have one more question.
Mhm.
So the one right before it, the Welch's T, can variance and standard deviation be like the same in this one?
Yeah, standard deviation is like if you're basic, like versus like variance. Variance is like, oh, you should talk about variance because that's the actual defined quantity. And so usually people say like, you'll hear a lot of statisticians in particular talk about the variance, but they really mean the same thing because you can get the standard deviation by taking the square root of the variance. So variance is usually represented by the sigma, lowercase sigma squared, and then standard deviation would then be just sigma.
Okay, thank you.
Okay, good
Those are
question.
all my questions.
Nice. All right. Hopefully you guys like having that time to ask any questions and stuff. I think it's useful. All right. Anything else though before we move on? No? Pretty good. Okay.